Welcome students. Today we will solve fourth problem on trusses and we will solve this problem with the method of joints. So let us start today's lecture. So we are given one truss over here and we are asked to find forces in all the members of this truss by using method of joints. And we know if we want to solve any problem on a truss, the very first step is we should identify what are the supports given in that truss. So in this truss we are given two supports, one is at joint A and second is at joint D. Now this support is a pin support, so it will offer two reactions, one normal to its surface, this is the surface. So normal to its surface, one along its surface. At joint D we have a roller support and this is its surface, so it will provide only one reaction, that is normal to its surface. So let us label these reactions now. So we have labeled normal reaction at joint D and we have considered its direction in upward direction. So this is just an assumption right now. So this is a reaction acting at joint D in y direction. Now let us label the reactions provided by this pin support. So first we will label the normal reaction. So this is the surface of the pin support. So normal to that surface, this will be direction. And we have considered its direction towards right. So this is just an assumption right now. So we have labeled it as a reaction at A in x direction. Now we will label second reaction at joint A along its surface. So we have labeled that reaction as well and we have labeled it as RAY, that is reaction at A in y direction because this is y direction, and we have assumed its direction in upward direction. Okay, so first step is find the supports given in the truss and label the reactions provided by those supports. What is the next step? Next step is find those reactions with the help of equations of equilibrium. So those equations are summation fx is equal to 0, summation fy equal to 0, summation m is equal to 0. So it means now our motive is find Rax, Ray, Rdy first. So let us apply the first equation, that is summation fx is equal to 0. So before applying this equation, let us first see how many total number of forces are acting in this truss. So how many forces are acting? 3 are reactions, 2 are external forces. So total 5 forces are acting in this truss. Now out of these 5 forces, there is only one force acting in horizontal direction. So it means from this equation we will get Rax equal to 0. So we got first unknown. Now we'll apply the second equation. What is that equation? Summation Fy equal to 0. Now how many forces are acting in y direction? There are 4 forces. Ray, Rdy. Both are acting in upward direction. So we'll consider these two positive. 50 kilonewton at joint B and 50 kilonewton at joint C. Both are acting in downward direction, so we have to consider these negative. So our final equation will be Ray minus 50 plus Rdy equal to 0. So in this equation there are two unknowns, so we cannot solve it. So let us write this as Ray plus Rdy equal to 100 and let us call this equation as equation number 1 for time being. Now let us apply the third equation of equilibrium, that is summation m is equal to 0. And let us find moment about joint A. So when you will apply moment at joint A, then moment because of these two forces will be 0. So we have to only find moment because of these three forces about joint A. So let us observe the moments because of these three forces about joint A. Let us first observe moment because of Rdy. Now this is the line of action of Rdy. And from moment center, if I drop a perpendicular onto that line of action, so that perpendicular will be of 8 meters. It means magnitude of the moment generated by Rdy will be Rdy into 8. And the nature of this moment will be positive because it is an anti-clockwise moment. So we will say positive RDY into 8. Now let us observe the moment because of next force, that is 50 kilonewton. So this is the line of action of force, and this is the perpendicular distance between the line of action and moment center, that is 8 again. But this force generates clockwise movement, so that is negative movement. So we will say minus 50 into 8. Now let us observe the next force. This is the line of action of this force, and this is the moment center. So perpendicular between moment center and line of action of force is 20 meters. And this force will also generate clockwise movement, and that will be negative. So it will be minus 50 into 20. So our equation will become RDY into 8, it is positive, minus 50 into 8, minus 50 into 20 equal to 0. So from here we will get value of RDY. And we got positive value for RDY. What is the meaning of positive value? That means the direction which we assumed at the start is correct. So RDY is acting in upward direction. So once we get value of RDY, we can say put the value of RDY in equation 1 to get the value of RAY. So we will do this, we will get RAY as minus 75 kilonewtons. So we got negative answer for RAY. So that means the assumption for RAY considered by us at the start is not correct. So actually it is acting in downward direction. So in the next calculations, when we have to use RAY, we have to show correct direction. That means in downward direction. So what we will do now, we will remove RAX. Why? Because it is 0, and we will correct the direction of RAY. So direction of RDY is same, and we have labeled its magnitude, and direction of RAY is labeled in downward direction, that is the correct direction. So we have labeled its magnitude also as 75. Now what is the next step? Next step is we have to find the forces in these members of the truss. So how many members are there? A, B, B, C, C, D, B, D and D. So there are 5 members. So we have to find 5 forces. And we know in order to find the forces in the members of the truss, we have to start with the equilibrium of a particular joint. And we know we can start with only that joint at which maximum unknowns are 2. So let us observe joint A first. Let us see, can we start with joint A? At joint A, there is one reaction acting and we know the value of that reaction. And at joint A, 2 members are connected, and in these 2 members we don't know their forces. So maximum unknowns at joint A are 2. It means we can start with the joint A. So let us start with joint A. So first step will be, we will say equilibrium of joint A. So in order to understand the equilibrium of joint A, we have to first draw its free body. So how to draw free body? First of all, label joint A on the paper. Then you should see how many members are connected to joint A. How many members are connected? 2. One is horizontal, one is acting at some angle to horizontal. So show both the members in that free body. So we have to draw one horizontal line and one line at some angle to the horizontal. So we have represented these 2 members AB, AD in this free body. Now after that we have to label the direction of forces acting in these 2 members. We don't know the direction of the forces acting in these 2 members. So if we don't know the direction of the forces acting in the members, we assume that those forces are tensile in nature. So in both the members, we will label direction of the force away from the joint. So we will label direction away from the joint. So in both the members, we have assumed that forces are tensile in nature and these are acting away from the joint. So this is member AD, so let us label its force as FAD. This is member AB, so let us label its force as FAB. Now after this what we do? We see, is there any external force acting at joint A? No, there is no external force acting at joint A. Then we see, is there any reaction acting at joint A? Yes, there is one reaction acting at joint A, which is of 75 kilonewton acting in downward direction. So let us show that reaction. So we have labeled that reaction in the free body of joint A. Then after that we see, is there any inclined force acting in that free body? Yes, there is one inclined force acting in this free body, that is FAD. So for that force we show its components. So this force is acting at this particular joint. So from this origin we will draw two lines, one along horizontal direction, one along vertical direction. So these two are the components of this force. Now let us label the direction of these two components. For that we have to see the direction of force itself. Now you can see the direction of force is away from joint. So in these two components also we will show direction away from the joint. You can see over here. Then after that we have to show the magnitudes of these two components. So for that, first of all we have to label the angle of this force with any of these two forces. So let us consider the angle of this force with its horizontal component. Let us say that angle is theta. So we need to find theta first. So where is this theta in this truss? That theta is over here. So in order to find this theta, we will consider this right angle triangle ABD. So we will say tan theta. That will be equal to perpendicular upon base. So perpendicular is 4, base is 8. So we will say tan theta is equal to 4 by 8. Or we can say theta is equal to tan inverse 4 by 8. So from here we will get value of theta as 26.56. So we have considered the angle of this force with horizontal component. So this component will be cos component, other component will be sin component. So let us label these components now. So we'll call this as FAD cos 26.56. We will call this component as FAD sin 26.56. So now we are ready with the free body of joint A. So what is the next step? Apply equations of equilibrium. So first equation is summation Fx is equal to 0. So how many forces are acting in x direction? There are two, FAB, FAD cos 26.56, and both are acting towards right. So we have to consider these two forces positive. So equation will be FAD cos 26.56 plus FAB equal to 0. So in this equation there are two unknowns. So we cannot solve this equation. Let us call this equation as equation number 1 for time being. Now let us apply the second equation of equilibrium, that is summation Fy equal to 0. So how many forces are acting in the free body in y direction? There are two, 75, FAD sin 26.56, and both are acting in downward direction. So we have to consider these two negative. So we will say minus FAD sin 26.56 minus 75 equal to 0. So from here we can get value of FAD. And value of FAD will be equal to minus 167.73 kilonewtons. So we got negative sign. So what is the meaning of this negative sign? At the start we considered the direction of FAD away from the joint, means we considered that this force is a tensile force. But we got negative answer. That means our assumption is wrong. It is not a tensile force, it is a compressive force, and it is acting towards the joint. Now we will say put the value of FAD in equation 1 to get the value of FAB. So when you will do this, when you will put this value minus 167.73 in equation 1, then we will be able to find FAB. So from this equation we will get FAB as positive 150 kilonewton. So what is the meaning of positive sign? That the assumption which we considered at the start is correct. So FAB is a tensile force. So from these two equations we have concluded that in member AB the force is tensile in nature, it is acting away from the joint and its magnitude is 150. And in member AD, we have a compressive force. It is acting towards joint and its magnitude is 167.73. So we have solved joint A and we have solved two forces. One is in member AB and one is in member AD. Now the next step is we will start with the next immediate joint. So for joint A, there are two next immediate joints, joint B and joint D. So we can start with any of these two joints. But before that, we have to satisfy rule number one, that joint should have maximum two unknowns. And you can see at joint B, there are only two members connected which are unknown to us. This member is now known to us. So at joint B, we have maximum two unknowns. We can start with joint B. Similarly, at joint D, we have only two unknown members. This member is known to us now. So at joint D, maximum unknowns are 2. So we can start with both the joints, either with B or with D. So let us start with joint B. So in the second step, we will say equilibrium of joint B. So for that, we have to draw the free body of joint B. So how to draw the free body? First of all, represent that joint on the paper. Then see how many members are connected to that joint. How many members? 1, 2, 3. 2 are horizontal, 1 is perpendicular. So show these three members in the free body. So we have shown one horizontal line towards right. We have shown one horizontal line towards left. And we will show one line in downward direction. So we have represented these members AB, BC and BD. Now in these three members we will show the direction of forces. We will start with the known member first. So out of these three members, this member is known to us, that is AB. Because for this member we have found the force when we were working on joint A, and that force was tensile force and magnitude was 150 kilonewton. So this member is known member. Now in this member we found that force is tensile in nature, it is acting towards joint B. So that means joint B will offer equal and opposite reaction to that action. So that reaction provided by joint B will be considered as active force in joint B. So in the free body of joint B, we have to consider this direction for this known member. So we have labeled that direction away from joint B. So this is a very important step you must understand. So we have labeled its magnitude also 150. Now other two members are unknown members, and we know in unknown members we assume force away from the joint, means tensile force. So this is member BC. So in this member we have labeled tensile force FBC acting away from the joint. So this member is BD. So in this member we have labeled tensile force FBD acting away from the joint. Now after this we should see, is there any external force acting at joint B? Yes, there is one external force of 50 kilonewton acting at joint B. So let us show that force. So we have shown external force at joint B, which is acting in downward direction, and magnitude is 50 kilonewton. Now after that we will see, is there any reaction acting at joint B? No, there is no reaction acting at joint B. Then after that we will see, is there any inclined force in the free body? No, there is no inclined force in the free body. It means we are ready with the free body of joint B. So it means now we can apply equations of equilibrium. So let us start with summation Fx equal to 0. So how many forces are acting in x direction? There are two, FBC and 150. 150 is acting towards left, so we'll consider this as negative. FBC is acting towards right, so we'll consider this as positive. So equation will be FBC minus 150 equal to 0. So from here we will get force in the second member, which is BC. So it will be equal to 150 kilonewton. And over here we got positive sign. Positive sign means the direction which we considered earlier, that was tensile force or away from the joint. is correct. So this force is a tensile force. Now we will apply the second equation, that is summation Fy equal to 0. So how many forces are acting in y direction? There are two, 50 and FBD, both are acting in downward direction. So we will consider these two negative. So equation will be minus FBD minus 50 equal to 0. And from here we will get value of FBD negative 50 kilonewton. So negative means the direction which we consider for FBD, that is away from the joint, that is tensile nature, is not correct. FBD is a compressive force. It is acting towards joint B. So from these two equations we have considered that in member BC we have a tensile force acting away from joint B and its magnitude is 150. And in member BD we have a compressive force, it is acting towards joint B and its magnitude is 50. So we have solved joint B also. Now we are left with only one unknown member, that is DC. So in order to solve for this member, what we have to do, we have to consider next immediate joint. Now for B there are two next immediate joints, joint C, joint D. So we can pick any of these two joints. So let us pick joint C. So we will say equilibrium of joint C. So for that, first of all, we have to draw free body of joint C. So how we can draw? First of all, label that joint on your paper. Then you should see how many members are connected to that joint. So how many members are connected? Two. One is horizontal, one is at some angle to horizontal. So show both the members. So from that joint we have shown one horizontal line and one inclined line. So this is member BC and this is member CD. Now we have to label the direction of forces in these two members. And we will start with the known member first. And out of these two, known member is BC. Because for member BC, we have found that force is a tensile force. It is acting away from joint B and its magnitude is 150. Now this force is acting towards joint C. So joint C will offer equal and opposite reaction. So that reaction will be considered in the free body of joint C as active force. So it means for this known member, for the free body of joint C, we have to consider this direction. So see, we have labeled that direction. Then second member is an unknown member for us. So we know in unknown members we consider direction away from the joint, means tensile force. So this member is CD, so we have labeled a tensile force FCD in that member, means away from the joint. Then after that we will see, is there any external force acting at joint C? Yes, at joint C there is one external force of 50 kN acting in downward direction. So show that force in the free body of joint C. After that we see, is there any reactive force acting at joint C? No, there is no reaction at joint C. Then we see, is there any inclined force in the free body? Yes, there is one inclined force FCD. So we have to resolve this force into its components. This is the origin of this force. So from this origin we will draw two lines, one in horizontal direction, one in vertical direction. So these two are the components of this force. Then we need to show their direction as well. So for that we have to see the direction of force itself. Now this force is acting away from the origin. So for these two components also we have to show directions away from origin. Direction away from origin. Now we have to label their magnitudes also. So for that, first of all we have to see angle of this force with any of these two components. So let us consider this angle, means angle with the horizontal component. So let us label that as theta. So where is this theta in the truss? That theta is here. So if I have to find this theta, I will say right angle triangle DBC. In this triangle DBC, we can say tan theta, that is perpendicular upon base. So how much is the perpendicular? It is 4. How much is its base? It is 12. So tan theta will be equal to 4 by 12, or theta will be equal to tan inverse 4 by 12. So when you will solve this, you will get value of theta as 18.43. Now we have considered angle of this force with this component as theta. It means this is a cos component and this will be a sine component. So let us label the magnitudes. So we will say this is FCD cos 18.43 and this will be FCD sine 18.43. Now we are ready with the free body of joint C. So let us apply equations of equilibrium. Let us apply the first equation, that is summation Fx is equal to 0. So how many forces are acting in next direction? There are two. 150 FCD cos 18.43. Both are acting towards left, so we'll consider these two negative. So we'll say minus FCD cos 18.43 minus 150 equal to 0. So from here we will get our last answer, that is FCD, force in the member CD. And you can see over here we got negative answer. So what is the meaning of minus sign? We have considered tensile force for member CD, that is away from the joint. But now we got negative sign. That means that assumption is wrong. So FCD is a compressive force. It is acting towards joint C. So we have found that in member CD we have a compressive force. It is acting towards joint C and its magnitude is 158.1. So I hope this numerical is clear to you. Thank you very much.